I'm the Cybersecurity Research Coordinator at the Federal Networking and IT R&D Program, or NIDRT. Many of you know NIDRT is the federal government's forum for coordinating research in various IT areas, including cybersecurity. The agencies of the federal government that fund research continuously refine and evolve their research objectives based on their mission requirements, state of the research, and national needs. One area of growing importance is privacy in cyberspace. Developing capabilities to achieve and satisfy various privacy objectives in cyberspace is a societal and national imperative. For the research community, it is important to examine what are the critical and foundational research areas and challenges, and what research objectives could guide the way forward. For the funding agencies, well-developed research objectives are important in order to form responsive research initiatives and programs. This panel has been organized with the goal of helping to clarify what is important in privacy research, with the view of impacting the national dialogue in this area. So it is my pleasure now to introduce Daniel Weitzner. He's going to be the moderator. He is the director of the Decentralized Information Group at the MIT Computer Science and Artificial Intelligence Laboratory. He also teaches Internet Public Policy in MIT Computer Science Department. During 2011 and 2012, Daniel was the United States Deputy Chief Technology Officer for Internet Policy in the White House. Among the initiatives on privacy and cybersecurity, he was responsible for the Obama administration's Consumer Privacy Bill of Rights and the OECD Internet Policy-Making Principles. Daniel is also a founder of the Center for Democracy and Technology, led the World Wide Web Consortium's public policy activities, and was Deputy Policy Director of the Electronic Frontier Foundation. So with that, let's welcome the panel, and thank you for coming and staying. Okay. You want this here?
Thomas, thank you so much. Good afternoon to everyone. Could I ask that someone in the back there pull the door closed if you're able? And we do appreciate you all staying. I really appreciate Thomas's work in pulling together this panel. I think the fact that we have now a large collection of federal research funding agencies and federal mission agencies with an interest in privacy is really a very welcome development, and I'm glad that they've come here to this conference to engage this discussion. I'm going to very quickly introduce the panel. As you see, there are a lot of us, so I discouraged the panelists from either having slides or making formal presentations. We're going to have a more informal question and answer discussion up here, and there'll be plenty of time for all of you to interact as well with us. So let me just very quickly introduce our panel. We have a really fantastic collection of people. On my far right is Betsy Masiello. She's the Senior Manager for Global Public Policy at Google. She has a BA in Computer Science from Wellesley, a Master's in Economics from Oxford, where she was a Rhodes Scholar, and a Master's also from the MIT Technology and Public Policy program. She's one of those students of mine who's gone on to much greater things, which is really great. Next to Betsy is Karyn Higa-Smith, who's a program manager and the Science Technology Director at DHS. She leads research projects in areas of identity and access management, as well as data privacy. And full disclosure, she's my program officer, so I may not be able to cut her off quite as much as the other panelists, but she can cut me off. Next to Karyn is Deirdre Mulligan. Deirdre's a professor of law at the UC Berkeley School of Information and the Berkeley Center for Law and Technology. She's a long-time both researcher, activist, and advocate in the area of privacy, and was part of the group that founded the Center for Democracy and Technology with me, so it's great to be with Deirdre. Next is Vijay Atluri over here on my left. Vijay is currently serving as Program Director at the National Science Foundation. She's also Professor of Computer Information Systems and Research Director for the Center for Information Management, Integration, and Connectivity at Rutgers. We're happy to have both Vijay and Karyn here from the research funding agency perspective. Next to Vijay is Joan Feigenbaum. She's the Grace Murray Hopper Professor of Computer Science at Yale and is well known for her contributions in trust management, privacy, anonymity, and accountability. And finally, next to Joan is Jeanette Wing, who is now the head of Microsoft Research International. She's also been, as many of you know, Professor of Computer Science at CMU and served as Assistant Director at SAIS and NSF, so we're really happy to have all of those different perspectives wrapped up into one person. I'm going to just very quickly kick off this panel and just take this moment to kind of give away my bias about privacy research. I think that if there's one thing that we ought to really work hard to take very seriously as a computer science research community about privacy is that privacy is an awfully complicated, complex set of ideas, and that any effort to reduce privacy to one single property of any system with the hope that we could just solve the problem of privacy with one swoop, I think is probably not looking at the problem broadly enough. And to illustrate that, I just take you for about 25 seconds in a walk through the history of privacy in Western democracies, at least, where at different times in history we've had really tremendously different priorities and perspectives on privacy, all of which are still with us today, but different ones of which get emphasized at different times. When the modern nation state was being constructed, we were principally concerned about making sure that the state, the sovereign, didn't have too much power over individuals, especially us Americans were concerned about those nasty Brits and the king. And so we part of our privacy thinking has always been about controlling how much power government has. As we had social revolutions in the 20th century, a lot of the concern about privacy was actually about what we would think of today as freedom of association and freedom of the press, making sure that individuals had the ability to participate in the democratic process and not have their political activities chilled by undue intrusion either from the state or from others. As the mainframe computer came along and you could look in the privacy literature of the 1960s and find that people were very concerned about whether the expanded data processing capabilities that those very powerful computers like IBM 360s and whatnot were giving to large organizations could result in people being treated unfairly. And you saw conversations in the 1960s that would mirror very much some of the privacy conversations we have today about big data. So we were concerned about fairness then. And I think that in the 1990s there was a particular kind of what I regard as a little bit of an odd detour. With the advent of the personal computer, there was what I think is somewhat of an illusion in the privacy world that individuals could exercise perfect control over their information and that we all as individuals could somehow protect ourselves from privacy intrusion without the help of anyone else. Lots of cryptographers, I will say, contributed great technical contributions during that period of time, but also may have led us to perhaps oversimplify notions of just what privacy is, that privacy, I think we now understand, is about a lot more than just secrecy. So I think the challenge that Thomas framed for us for this panel is to try to understand the broad range of concerns that a computer science privacy research agenda would address. I'm going to kick off this discussion by asking each of the panelists, I'm going to begin with Jeanette, I'm going to ask them to just very briefly describe what they think of as perhaps their favorite or most interesting privacy research result. It doesn't necessarily have to have been a perfect solution, but I'd like us to just start by getting a picture of the breadth of topics that have come under the rubric of privacy research. So, Jeanette, what's your favorite?
Right, and am I on? Yes. Danny said that we couldn't talk about our own research, so
Oh, well.
that was a rule. So I'm actually going to break his rule to begin with, because I want to mention two pieces of work for different reasons, but to explain and show the breadth of research in privacy that's possible. And one is the work on differential privacy coming out of Microsoft Research and others, but especially Cynthia Dwork's work. And the reason I mentioned differential privacy as a piece of work I admire in privacy is because it was, at least in recent times, a completely new approach to a formalization of privacy, of certain privacy property. And I very much admire work that has formalization, clear assumptions, clear model, clear proofs of properties, and so on. So that's one piece of work I admire. On the other hand, there's a body of work that I very much admire coming out of Alexandra Akisti's work on economics and social science and privacy, and a lot of very, very surprising results that come from doing behavioral studies and sort of understanding user behavior in when privacy is of concern.
Joan?
So I think my favorite example of a successful privacy research result or body of results in recent years is the Narayanan-Shmatikov results on de-anonymization. And the reason I admire that work a lot is because I think it really explains something extremely well and extremely clearly. De-anonymization was certainly something that people were aware of. There was just this sort of general vague dread that all kinds of data about us that were supposed to have been anonymized could nonetheless reveal stuff about us, and there had even been well-publicized examples, but you couldn't really explain to all that many people, so exactly how does that work? Exactly what went wrong with this attempt to de-anonymize data? And there was this feeling that somehow there's this black magic that every once in a while happens and somebody can de-anonymize something. But the Narayanan and Shmatikov work actually explained in very precise ways what properties of supposedly anonymized data sets lend themselves to being de-anonymized, and algorithmically exactly what do you do to sort of coordinate supposedly anonymized data with other data that's out there in order to de-anonymize. So I thought that was a really great example of privacy research. Now, unfortunately, it's an example of a type of not just privacy research, but security research in general that is very often very successful, but not really completely satisfying, in that it shows how things can go wrong. It shows how you can break things. And I think in this community, we really love very general, clean, clever ways to break things. And we usually accept those papers, but we need more than that. So.
Vijay.
Okay. Actually, I have been at a NSF-PI meeting more than a decade ago in Pittsburgh, actually, at CMU. There was a birds of feather session on data aggregation and privacy. And I remember much of the discussion was about what is the definition of privacy? What is the metric for privacy? And we have come quite a bit far in that direction, and I agree with Janet, and I also have my favorite one is on definition of privacy. The whole body of research from anonymization and the different improvements of anonymization, like T-closeness, L-diversity, and all those aspects, and now the differential privacy are the actually fundamental contributions, in my opinion, to the privacy research. And both of them explain why. And also I have, because I come from a database perspective, I have another favorite one, the one on privacy-preserving data mining work by Rakesh Agrawal, and similar work in the crypto community by Pinkas. This actually spawned a lot of body of research, and it is now applicable now to the cloud and the outsourcing community as well. How can you, in a privacy-preserving way, analyze data and infer or learn about the data?
I'm actually feeling really happy that I know all of the technical work that's been mentioned so far. And I've had the great fortune to collaborate with, I think, everyone that's been mentioned, too, and not necessarily towards a paper, but as the non-technical person, I'm feeling really good about that. And may have chosen one of those papers, but to bring a little breath to the conversation, I guess I would say another body of work that I think has been very important and I think needs to be continued is work on conceptual work, right, to pick up on what Vijay was saying. So what does privacy mean, right? And Danny knows, he kind of started off this conversation, that privacy means many different things. Helen Nissenbaum will add in many different contexts, which I think is an important overlay on how we think about privacy. But I myself think that privacy is basically an essentially contested concept. In fact, privacy, this term is there so we can debate its meaning in any given setting, and often it actually operates at multiple different levels. And some of the computer science work which has defined privacy in a crisp way, whether it's about de-anonymization threats, or it's about Cynthia Dwork's work looking at differential privacy and how we query data sets, or it's about homomorphic encryption. All of those are really useful because they've defined a problem. I think that moving forward we need more of that conceptual work to actually define what privacy means, and it's a really, really rich conceptual space, and I think that that work isn't work that computer scientists should be doing on their own. I think that that's a great place for collaboration.
Thank you. Karyn.
Coming from a federal government program manager, this may sound cliche, but TOR, and it's something that, you know, it was funded by the federal government, NRL, the Naval Research Lab, and it was meant for military and government use, but now look at it, it's used worldwide and by us as consumers on the internet, and that is something that I would like to emulate, and I think it's a great example of transition, which is our #1 goal, from transitioning from research to operations.
Thanks. Betsy.
Yep. So being at the end of the panel, I have the great joy of having already had the works I would have think of be mentioned. So I will just sort of repeat and add a little bit of color. I sort of had two works that would have come to mind in case I got substituted on, and both of them have been mentioned. The first one is Alessandro's work on behavioral economics and sort of looking at decision-making in real time and how users actually do value some of the exchanges that are happening in this economy. The second piece of work, and I would sort of echo everything that Deirdre just said, is Helen Nissenbaum's work on contextual integrity. And I would agree and sort of emphasize that more conceptual work is needed in this space. And it, you know, it's not necessarily technical in nature, but having technical folks work on that conceptual work together with philosophers and others will bring a lot more value to it.
Thank you. You and the audience will have a chance to nominate your favorites too towards the end. So one thing that I think is interesting, if you look through this list of favorites that have been identified, a significant majority of them are really, in some ways, traditional information security results. They're results about restricting access to personal information in one way or the other, important and interesting results, but much of the work might be actually just characterized as security results. I think that one of the challenges that Thomas has kind of put out for us is the question of whether we ought to be now some of the results are decidedly not that, and that's worth noting as well. The work on contextual integrity, some of the broader definitional efforts that were mentioned go beyond the application of techniques that I think have been well developed in the computer security community. But I do want to focus on this question and ask the panel for thoughts about when you think about privacy research, do you think about it as a subfield of computer security or information security or cryptographic research? Do you think about it as something separate? How do you think about it? Joan, I wonder if you could kind of start us off on that question.
Okay, so I think you have to first say what you think information security research is. So I guess I think of information security research extremely broadly. I think it's that information security is about formulating and improving the properties of and enforcing appropriate policies for the handling of security information, of sensitive information. Okay, and yes, I think privacy is one aspect of information security, and I think one class of policies that you need to conceptualize, as Deirdre pointed out, and that you need to define properly, as Jeanette and others have pointed out, is privacy. Okay, but it's not the only one. And I certainly...
That's a security result.
Right.
It's fun.
Go ahead. Okay. Maybe start your point again, just so we get the thread.
I think of information security as a set of questions about, how do you formulate appropriate security goals? How do you define them precisely? How do you prove properties of suggested solutions? How do you formulate appropriate policies, and how do you enforce them in context? And I think privacy is one aspect of information security when we conceive of information security that way. It's not all of it, obviously, because we need, as we've just heard from multiple quarters, we need to define privacy appropriately in context. We need to formulate appropriate policies and norms and rules for dealing with it, and then we need to enforce them. So cryptography is something else Danny had mentioned. I see cryptography as a set of technical tools that can solve some security and privacy problems, but not all of them. So it's nothing, I wouldn't say privacy is a subset of cryptography in any way, not at all. So why, when we talk about our frustration with, it's just sort of how little success the technical community has had in making the public at large feel that its privacy is being respected, which is not at all to say there hasn't been successful privacy research. There has. There have been a lot of great privacy research
That
results.
was the privacy police.
Right. Yeah. I think I can generalize to some extent about where information security research in general has been successful and where in actually providing security in practice and where it's been less so. I think that information security, very broadly conceived, as I tried to just conceive and describe it, includes computer security, machine security. It includes a set of problems in which the main goal is to say, you, the owner of this resource, you, the party that have legitimate right to control this resource, have to take responsibility for it and control it. And here's a bunch of technical tools that can help you do that. You know, so if you're running a company network, it is up to you to use appropriate authentication procedures to make sure that only authorized people can get onto your network. And without going so far as to say that's a completely solved problem, I think there's been much more progress on that kind of thing than there has been in the less clear, less about ownership and control aspects of information security that we're interested in. And I would say privacy, as most people understand it, falls into this latter category, where we're not really talking about something where there's a very clearly defined resource and it's clear who owns it or who is supposed to control it and take responsibility for it. We have a much more multifaceted, multi-party set of ideas in mind when we talk about privacy. And in particular, we can't completely achieve privacy by telling people control access to information or restrict access to information. You can't, that's not sufficient. The problems like differential privacy, that can be conceived in terms of controlling the manner in which information is accessed. Like setting up a database of sensitive information in such a way that access to it does not reveal information about individuals. Okay, that is, fortunately, one of those situations in which, with a very brilliant piece of work by Cynthia and others at defining that property carefully, you can get somewhere. But there's a lot about information privacy in online life that's really not that simple. I mean, it's really not clear who owns this information, who should have a right to access it, and who should control it and how. So that's where I see the difference between places where we've been successful in security, which is really more about computer security than information security usually, and where we've been less so, is that when we can't reduce things to control and access, we have less success.
I want to ask, in particular, Jeanette and Deirdre, whether that's a characterization of privacy research that rings true to you, and others should feel free to chime in as well.
So I will speak. The reason Danny wanted me to respond to Joan is because he wanted there to be some debate on this panel. And so he already tipped me off as to what Joan was going to say. And I already knew that Joan was going to define information security broadly enough so that it'd be really hard for me to argue with her. But first of all, I think there's a difference between what would go into a research agenda for privacy and what constitutes, what is privacy. I think there's, just as Joan is saying, she defined things broadly enough that one could argue that it is yet another property or desirable property or correctness condition we want of our system. And then it is about specifying the policy or specifying the desired property and proving that the system under question satisfies those properties. And then you throw in security or correctness or reliability and privacy and so on. And I think the methods can be very similar. My view about a research agenda for privacy is that it really needs to draw on all areas of computer science and beyond. And in fact, my personal opinion is that in privacy research, except for a small community of computer scientists like Joan, who have been working in privacy for many years, a lot of the research has been done outside of computer science, more in the legal arena, the ethics, philosophy, social science, And so what I would like to see is more computer science and researchers in core areas of computer science take on privacy as a new challenge, much as areas of computer science have taken on security as a challenge. I'm thinking in programming languages, for instance. So I see privacy research as being able to draw from cryptography as a set of tools, from statistics as a way of defining measures of privacy, to systems, understanding the context in which people might care about location privacy, for instance, to HCI, understanding the user aspect of it, to economics, social science, and so on. So I really see it's spanning the gamut from very formal, traditional formal areas of computer science all the way to areas beyond computer science. Now, if you take that view, one can then say, well, how is it any different from what people do in security research? And I think security also has broadened in its view of what strengths from areas of computer science can help play a role. And I already mentioned programming languages as one example. The flip of this, and this is my segue into the question Danny didn't ask me, and that is, what is the role of the federal government in this? Where should privacy research be?
So Jeanette, I'm going to pause you for just a minute. We will come to that, I promise you. But I actually, both of you, I want to push the two of you a little bit before coming to Deirdre, because both of you suggested that there's, yes, you do, but both of you, Jeanette, you suggested that there are important computer science techniques that could be used. I think you suggested to be able to prove certain correctness results about systems behavior as to a certain desired set of privacy properties. I guess my question is twofold to either of you. A, do we know how to do that today? And B, why does it even matter? I mean, there are a lot of people who have built lots of techniques, lots of tools that make certain privacy contributions, and most of them don't actually, perhaps with the exception of differential privacy, most of them don't have that sort of theoretical foundation. Why does it matter to have that, and is it something that we already know how to do, or is there work to do to develop that sort of foundation?
I do see it matters, and that's what the reason is. I think it's important with whatever result research you're doing is to understand what the model of your system is and what the property you want of your system to hold, and that is usually based on some mathematical structure that defines quite clearly the behavior of the system, and some specification, whether it's another mathematical structure or a logical formula that captures a property such that you can do the formal reasoning. Now, that's not to say that every system has to be formalizable before we can actually use it, but it's important to understand what we can and cannot rely on of a particular system, and having provable properties about a system is much better than crossing your fingers and hoping it works in the way you'd like. So I do think the computer science community that focuses on formal foundations have a lot to offer in what I would call science of privacy, much as there's been a lot of interest recently in science of security.
Do we know how to do it today? Joan?
Do we know how to do what exactly? Formally prove privacy properties? Well, in some cases. I mean, yes, I think that there's a bunch of work on privacy and private information retrieval and differential privacy, and there's some things we know how to prove. There's a lot of things we don't know how to prove. There's a lot of things we haven't even formalized. So of course we can't prove anything about them, because proofs are inherently about formalism and about formal concepts and formal claims. Okay, so I guess the reason I would say that formalizing ideas of privacy, and I didn't say idea singular, multiple ideas, drawing on many disciplines, and, as Helen would put it, looking at context. Poor Helen. I mean, so far no one said anything bad about her, but it's almost like we think she's here, Anyway, I think that the reason I would emphasize formalism and making sure that we define terms correctly, and that's an iterative process, by the way. Don't expect the first paper in the subject to have the perfect definition. But the reason I would emphasize that is that the purpose of this panel is about privacy research. It's not only about how do we, in practice, give people a sense that their privacy is being respected, but how do we do privacy research? And I think that if you look at the general class of research areas that the people in this room care about, you see that the successful ones usually do involve formalism. I mean, I think that cryptography research has been immensely successful now for the past 35 years. And one of the major, in fact, probably the most important cornerstone of this success, the important foundation of this success, was novel and interesting and productive formal definitions of the properties of crypto systems, the formalizing of what an adversary is and what a secure crypto system is. And so I would say that if we're going to do successful privacy research, we need good formalism. But yeah, okay, but we need good formalism. Now, that is not all we need. Okay, and you notice that the example I gave of what I thought was a prime success, a very good success of privacy research in recent years was not purely formal. The Narayan and Shmatakov de-anonymization work was not purely formal. I like the fact that it has an algorithmic component and it has theorems that you can prove, but it had a really breathtakingly successful experimental component as well, in which they took this technique that they were able to describe precisely, and they used it on real data, and they got real results. So I'm not in any way saying all we need is formalism, but I think that really good, solid research usually involves formalism.
Okay, good. Deirdre.
I just wanted to add one other practical reason. It's not so much formalism or not formalism, but where scientists with clear results can really help the conversation, and that is in the DC community. We see lots of legislation, and people who are non-technical experts come up with, say, privacy legislation or policies that are not technically feasible to implement. And I think it's our responsibilities as scientists to understand what's possible and what's not possible from a scientific point of view. And that often does mean crisp definitions and then being clear about assumptions and so on. But it doesn't have to be, writing all those formulae in some Koch theorem prover or something. It's really...
Deirdre.
I wanted to say something. Oops. Is it on?
Yeah.
Yeah. I wanted to say something perhaps funny first, which is, it seems pretty clear, I'll be completely stereotypical, but privacy is pink and security seems to be pretty blue. I'm just saying. Betsy was suggesting it's because privacy is soft, and not in a simple, fuzzy way, but in a messy, complicated way. And I think there is some truth, but I also think that partially goes to problem definition. And if when I look at information security, right, as confidentiality, integrity, availability, clearly that is not privacy. And I know that you heard from Anupam Datta earlier today about another kind of system property, right, this purpose limitation. I hope I'm getting that right and not butchering it. As a potential system property that one could also prove, which is clearly related to privacy and I think related to security too, but I think it's a kind of additional property that one might think about developing. It's a formal concept and developing proofs, etc., and I think that's useful. But I think in many ways everyone's realized that information security defined as information security only gets you part way to understanding what security means, right? And if we look at the debates about cybersecurity, right, that is a conversation about securing whom against what threats at what costs, right, which clearly is about defining the problem somewhat differently than just confidentiality, integrity, and availability. But it's also about the interplay between policy and technology, right? Because knowing how to deploy those things is also part of the solution space. And I would say that in the privacy context, we both have some concept issues, right? Conceptualization, what sorts of privacy is important, but I think it also has that messy nature of needing to understand the problem space in a way that we can do better research. And so I think privacy is certainly not a subset of security, for sure. I do think that one of the gaps in privacy right now, one of the big mantras from policymakers is that technical people should be doing privacy by design. Use all those tools you have for figuring out how to design for privacy, all those threat models and design patterns, if you could just use them. And of course you're all like, what are you talking about? We don't have any of those things, right? Or we have very few of them. And so I think there's some really fruitful work looking at the sort of methods and techniques that we've used on the security side and thinking about their applicability to privacy to the extent that we have the right concepts to animate the use of that research agenda. Yeah, so I'll stop there.
Okay, thank you.
I could go on, but I won't.
So we're talking here about what goes into a privacy research agenda, how it would be structured. This, of course, is not an abstract question. It's a question that the three panelists we haven't heard from as much are actually in the thick of. And I want to start by asking Vijay and then Karyn just how you have approached the development of your privacy research agenda. Vijay's got a major program at NSF that has a major privacy component. Karyn has a new program at DHS, which is very important, has a substantial privacy component. And then we'll come to Betsy, who's looking at this from a commercial industrial perspective. We're building from a company that builds lots of infrastructure and services and has to deploy a lot of these ideas and maybe has to grow some of your own. So Vijay, could you just tell us a little bit about how you think about the requirements that go into the privacy component of your program?
By definition, NSF doesn't set a research agenda for the community. Normally, we fund the best research best proposals that we actually receive. So from that perspective, I don't think I can set requirements for the community, but I can certainly talk about the various the research agenda that is being funded by the SaTC program, the various flavors of the SaTC research agenda. I would say about I was just counting the number of grants that we have actually funded in the privacy area. Out of 400 grants, about 70 of them are somewhat related to privacy, working on problems related to privacy. So it's really not bad. We are more or less about funding 20% of research in the privacy-related areas. And some are actually looking at the definitions of privacy, the differential privacy work, and looking at the adversarial knowledge and how do you actually prove privacy guarantees with the different assumptions on the adversarial knowledge, and looking at the different applications settings that actually bring new privacy challenges such as cloud computing, social networking, the new applications that are out there. Even Googling, search is a privacy challenge, And the whole human aspect is the new thing that you have to take into consideration when it comes to privacy, which is not part of security. So how actually people perceive privacy, that was not, when you talk about security, actually you are talking about the systems, and also even in the information security side, you have security policies and, how do you enforce these policies through either access control mechanisms or cryptographic techniques. But when it comes to security, if you have data, the same data, if you take from one perspective that could be perceived as privacy preserving, but from another perspective it may not. So users may perceive it differently when it comes to the privacy as opposed to security. So this whole social and behavioral economics aspect of privacy is also part of our security and trustworthy research agenda at NSF. So our SaTC program has been now a NSF-wide program, which includes this directorate.
Yeah, great, thank you. So Karyn, you launched a data privacy research portfolio. Tell us about what the motivation for doing that was and how you think about the scope of the work there.
So we actually...
Just bring the mic a little closer.
Oh, can you hear me now?
Great.
So we've actually started a privacy research back in 2007, but then it was cut off because of budget cuts. And although the cybersecurity kept increasing their budget, but now we just restarted basically the data privacy research because of the increasing capability gaps that we've been getting from our DHS counterparts within the Homeland Security environment and enterprise. So we back in 2007, we've never stopped meeting, even though our budget was decreased. But so we've never stopped meeting, but it's a privacy working group within the department, and it consists of the privacy officers within the Homeland Security, and they provided us with, we have over a dozen requirements, capability gaps, requirements from the Homeland Security mission. So because of those unfunded requirements, they have they've accepted our proposal to restart the program. So we have about $15 million for the next 5 years to do some research and development in this area. So in the past, some successful transition was best practices of the use of data anonymization tools. So there's, a number of commercial products out there, but in particular, there was a requirement from one of our components, ICE, using in a decentralized environment, how can we anonymize some of this information so we can use more of it or do some better research and testing and training. So that was one successful transition that was more, it wasn't technical, it was more analysis of commercially available technologies and best practices of the use of those technologies. But in the future, we're looking at, based on the capability gaps we've acquired is some things like data tagging, data level tagging of personally identifiable information, and policy-based access to those data. So that's some things that are looming in the future. And we do have an open solicitation on BAA2.st.dhs.gov for researchers that are providing some tools and technologies, and I am interested in more technical type solutions, but also I'm open to the behavioral parts because what I keep hearing about privacy versus security is mostly that privacy is focused on the intention of use of that information. Well, how do you code that information? How do you code behavioral and the human factor part of it? So I'm interested in both aspects. And something that we are currently funding is we're funding MIT, the CSAIL, which is Danny is one of the research performers on it, but is developing a policy reasoning engine. So this is very computer science and technical solution. This is which is one of the reasons I really like this. And the other reason I like it is because every time I talk about it, people want to learn more, they want to collaborate, and they want to partner. But it's basically a policy reasoning engine. The use case was in an information sharing environment, such as fusion centers. So fusion centers is basically a center where an operations center where law enforcement or first responders would centrally share information or disperse information. So not every state has a fusion center, but some of them are, shared by states in a jurisdiction. But basically, if one analyst from one fusion center needs to share, law enforcement type data to another fusion center in a totally different jurisdiction, they have to consider the federal laws, privacy laws like the Privacy Act. They have to consider state laws because every state has their own version of the way they disseminate PII. So what MIT has done is digitize the privacy laws and policies, and then they are gathering information from different disparate sources and then correlating that information in this policy reasoning engine, and then providing a yes or no to the analyst trying to share information whether or not you may be violating this part of the Privacy Act or Massachusetts law. So it's basically providing an informed decision. So it's providing accountability and auditing. So that is something that is currently in progress. And then we actually presented this project at an NSF meeting, and through that meeting, we partnered with HHS because they're interested in using this type of policy reasoning engine in the health information exchange environment. And then we're also looking at piloting this reasoning engine in a state juvenile justice information sharing environment because they have 12 different agencies that they have to make sure that they coordinate with in order to share information, and they have not only state policy, privacy policy laws that they have to make sure that they're complying with, but also the HIPAA laws. If a teenager gets arrested, they need to find out certain things about their medical history, or they need to find out information about their education. And then there's this FERPA law, which is also protecting the children's information about their education. So there's a lot of laws that they have to comply with, and we're trying to automate the process.
We're now considering reducing the number of laws as an alternative to more rapid conclusion of the research. Seriously.
It's funny that you mentioned that because the U.S. is, kind of unique in that because other countries, they are more federal-based laws. But here, we have 50 and plus jurisdictions and states that have their own way of, sharing information that contains PII.
Karyn, thanks. So Betsy, you have the exciting task of looking through what's available from the academic community and elsewhere and inside your own research labs. How does the privacy research space look to you? Is it producing what you need? Are there things that you need that aren't there? Or?
So just to sort of set the context a little bit, is this on? In terms of my role at Google, I don't have oversight over our technical research or even implementing products. But looking at the research that comes out from a perspective of sort of trying to solve the problem, push the needle forward, many different things have been alluded to here, and I'll just sort of summarize a couple things that I've heard repeated in numerous different ways across the panel. The first is that privacy is unlike security in the sense that it's hard to formalize a definition of the problem. I'd sort of add a second observation to that, which is depending on who you talk to, the formalization of the problem is going to vary, and it may vary dramatically. So if you're a web company operating at global scale, you've got users around the world, you've got an infinite number of formalizations of that problem to deal with. And here I'm talking about sort of user interaction more than anything, but again, for a company that's sort of consumer-facing, that's something you're going to think a lot about. The second observation I would make, which has been alluded to most recently here by Karyn, I think is the complexity that the systems that we're talking about are operating in is increasing, both in its technical nature and also in its sort of policy, regulatory, legal nature. It is true that the US has more privacy laws than elsewhere, but it's also true that in Europe, each of the 27 member states transposes the data protection directive to their local jurisdiction, and Germany has 14 different DPAs. And so actually we're talking about like many, many, many different laws around the world. And then on top of that, the technical complexity of any given website operating, for any different number of browsers, mobile devices, laptops. You've just got a lot more complexity as a company to deal with these problems. So what I see there, sort of synthesizing across those two observations, is this is a really hard problem. It's not something we can easily formalize and set out sort of a strict answer to that's going to be helpful in implementing things for companies that are actually building products. What I do think the security community could actually help the privacy community with is all the lessons that security researchers have learned about vulnerability assessment, about sort of testing, rapid response to bugs, all of those things. Some of them are going to be technical in nature. I think some of them are actually more process-oriented, organizationally focused, right? How do you actually build an organization that can respond to a bug rapidly? If you're operating one of these really complex systems that has how many different iterations of a problem definition, how do you appropriately sort of poke that system enough times that you're identifying the vulnerabilities that you need to be responding to? And that's quite a different sort of set of problem definitions than I think we've discussed here, but it's a set where I think this community in particular could bring a lot to bear on the research discussion.
Thank you. So there's one final question that I want to get to, and then I also want to get to everyone's questions. So think about questions that you have for the panel. I want to start by asking Deirdre, how do you see the evolution of the multidisciplinary nature of privacy research? You've worked with lots of different, across a number of different disciplines. We've heard about law, we've heard about economics, we've heard about psychology, we've heard about a number of traditional computer science disciplines. How do you think as you look at research challenges going forward? What's been your experience about the way that multidisciplinary work happens or doesn't happen?
It's hard. As a lawyer, the first challenge is also always trying to make sure you understand that giving you advice, like legal advice, is not research for me. And then we can get to kind of defining research problems. I think one of the huge benefits as somebody coming from the legal profession is that because computer scientists, as Joan pointed out, are very, very focused on, at least some of them, on formalization and proofs. The law, you might be surprised to know, doesn't really operate all that well with that model. People are pretty comfortable drafting law to deal with today's problem based on some metaphor that may have been illy chosen or at least doesn't really age very well. And I'll give you a really concrete example that Danny and I were talking about before, the Electronic Communications Privacy Act, which is a law that is being hotly debated at the moment and which will hopefully be reformed so that it actually provides some semblance of privacy. Today was crafted at a time.
The law is.
The law it's the key law that provides different levels of protection, both different standards to govern law enforcement access and different process protections for how they gain access, right? From going to a court and actually making an argument to a rubber stamp approval, right? And different standards. Is it reasonable and perhaps going to be useful in an investigation, or does it need to be clear and convincing evidence, right? Like those are the two dimensions it varies on. And because it was motivated by the way in which networks were being used at the time, which was for email where you dial in and you download your stuff and storage was expensive, so it disappears after 3 months, right? So there was no information stored in the cloud or on some remote server, or because we were talking about batch processing off-site, right, taking a bunch of data. The core metaphor that motivated our privacy law was one that was based on a first-class mail analogy where the outside of the envelope, right, both the identity information and the transaction data, the signaling, routing, how to get something from one place to another, was viewed as available, and the content, right, your letter in the envelope, which was what was viewed as sacrosanct. And so understandably, the protections for the data out here are relatively weak, and the protections for the data in here are relatively strong. Well, fast forward today, and what people are using is quote-unquote platforms for user-generated content, where the stuff on the inside of the envelope is all over the place, and what they're trying to withhold is, the stuff on the outside of the envelope, right? The transactional data and and their identity. And so the law, because it didn't actually have a robust conceptual model of what privacy might mean, it was motivated by a metaphor which frankly hasn't tracked very well with the way in which people use technology today. One of the enormous contributions that I've found in my collaborations with computer scientists and mathematicians specifically is that they're really, really picky about concepts and models. And I think that there's some really, really fruitful work there to be done across disciplines. So that's one particular example.
Great, thank you. We have 9 minutes left. I want to ask if there's any members of the audience who want to pose any questions, or please come to the mic. There's at least one right here in the center of the room. Come on up to the mic, and if you run out of questions, we'll talk amongst ourselves. But please go ahead. If you're willing, please identify yourself. If not, you don't have to. And if you want to pose the question to a particular panel member, that's fine, or you can throw it open.
Okay, my question is about the ethics of privacy in law enforcement and compelling people to give up passwords. So someone is investigated in a computer crime case, and, Fifth Amendment, you can't incriminate yourself, but then you've encrypted your hard drive. And this question is posed to Karyn and Deirdre. Could you go back and forth on what you think applies in this case?
So Deirdre and I are trying to remember what the current state of the law is.
Yeah. I mean, right, that you can be required to turn over a key, that isn't considered incrimination, and then there's been some cases, I remember talking about this with Dan Bonet about, right, so so when we think about incriminating, we think about it, it's about content and speech, it's not about function, right, and so First Amendment law tends to differentiate between expressive content and kind of functional speech. And I actually don't know what the last case was looking at how to consider a compulsion to turn over a password. But it's not, I don't believe it's settled, like it's not like it's gone all the way to the Supreme Court at this point. But this question about how to think about a key and how to think about the functional aspects of something that is otherwise expressive, right? So code is expressive, right? It has First Amendment protection. However, unlike when I get a recipe to make a cake, I actually have to do something. There's some human agency required between the recipe and the production of a cake, where I have a link, right, that may be expressive, but the minute I click on it, it also makes a cake, right? It does something functional. The courts have really struggled with that particular issue, that kind of trying to tease out. And when the thing that is functional is also expressive, it becomes quite complicated.
So the distinction that courts try to make in asking the question, what can they force an individual to disclose? You can be forced to disclose a physical artifact that you have. Courts don't like to allow government to reach into your mind and force you to disclose a password, a secret that you have in your mind. The problem is that distinction between, first of all, I'm not sure that most of us really can hold suitably strong private keys in our minds. So it's an example of a situation where certainly technical expertise has been necessary and will continue to be necessary to help the legal system to evolve, to apply these important principles, which are really about not invading too far into people's mind, but still providing law enforcement access to information that they need to solve crimes. Karyn, I don't know if you have anything to add. For the record, that none of my grant with Karyn has anything to do with self-incrimination. Thanks. Next question.
Rachel Greenstadt, Drexel University. I've been hearing, at least from the technical perspective, privacy kind of discussed in a number of different frames. I mean, there's sort of the math frame where you think about defining privacy and proving things about it, and there's sort of an engineering frame where we need tools that allow us to have certain privacy properties. And then there's sort of a scientific frame where we need to understand what privacy is and what people are doing with information in like the natural world or the artificial world that we've created. Is it possible to kind of, and there are lots of different strains of research that go along these lines. I wonder, is it okay for it to maintain, for privacy research to be separate? Does it need to be integrated between these frames or not? What is your guys' take?
So I think you're absolutely right that math and science and engineering, and many other technical approaches are part of the privacy agenda. I would say that it's legitimate and actually necessary that these things, that the research proceed both separately, in the sense that there should be people doing purely mathematical treatments of various privacy concepts. There should be people building systems that they claim preserve privacy in some way, and testing them and proving properties of them, and whatever. But much as it's fine to have some disciplinary or very area specific research, you also need to have communication, between these things. So I think that one of the now flourishing, but perhaps still, to be played out, questions about cryptography, which is mathematically really successful, has been anyway for the past 35 years, is to what extent can it actually be made an engineering reality? To what extent can all of these mathematically beautiful results that cryptographic theory has produced actually be woven into useful protocols that remain rigorously analyzable and about which guarantees can be made? So I think same thing with privacy. I think we need formal and rigorously analyzable privacy concepts, but we also need to engineer them into systems. So both, I guess.
Anyone else?
I agree, and there are also the societal, not just math and science and engineering, but I think they're what I would call the social, behavioral, and economic science aspects of privacy that come into play as well.
So can I actually, on
Thinking of
social,
science pretty
behavioral,
broadly.
and economic specifically, I think it's something that just hasn't been mentioned here at all, that maybe should be mentioned, given that to some extent this is a research agenda or research, how do we go forward with privacy research? So I think that one huge problem with privacy, one reason that people in general, including technical people, decry the terrible state of privacy in our online life is that there's sort of information that is collected or is produced or is transferred for what seemed to the people involved at the time to be purely commercial purposes and fairly well-defined commercial purposes. There's all kinds of electronic commerce going on in which sensitive information is created and used appropriately. And one of the big anxieties about privacy is, A, a lot of this information, while created in a fairly well-defined context and perfectly appropriately shared or transmitted in that context, then gets sold or brokered or used in some way in a completely different context. Now, as long as that's a completely different commercial context, I think that may be wrong and we may complain about it, but there's a limit to how damaging it is. There's also this whole question, and in fact we have a DHS representative here, there's this whole question about completely non-commercial uses of sensitive information. There is national security issues, there's law enforcement issues, there's counterterrorism issues. So, one really big problem with information that, this massive amount of sensitive information that's being created in the commercial realm is that it's incredibly fungible and it can somehow all of a sudden wind up being used in contexts that I would consider just fundamentally different and far more serious than a commercial context.
Okay, thank you.
And I think that's an important thing to put into this whole research agenda, is do we want to sort out commercial sensitive information from
I'm going to let
the rest?
Karyn comment on that, and then we'll go to the next
I
question.
just want to poll the audience. So how many are afraid of UAVs? How many feel safer?
Drones. Sorry.
Are you afraid of drones?
Sorry, unmanned air vehicles, drones, flying over your house or following you to the shopping mall? Yeah, in the U.S. And then how many feel safer? How many are
We have a radically uninformed audience about drones, disinterested about drones.
I don't think you can conclude
Hold on. All right, I'm going to, with the audience's indulgence, I want to ask the next two questioners to both state your questions, and we'll do one quick response to all of them, because we want to let all of you go to the drinks.
Jonathan Smith, UPenn. How do we think about biometrics?
Biometrics. Okay, next question.
So yeah, this is something that I'm Álvaro Cárdenas from the University of Texas at Dallas. So I have a question that has been bothering me for about a year and a half. So I think about 2 years ago I knew what privacy was. So someone gave me a problem, I knew, okay, this is a privacy problem and this is not. But about a year and a half I was participating in a panel committee on whether accepting a paper or not.
Speak just a little slower if you could.
Oh, sorry. Yeah, that's.
I know I was rushing you, but now I'm slowing you down.
Yeah, it put pressure on me. So I was participating in a panel committee on whether to accept a paper or not to a conference, and the paper had privacy in the title, but it was dealing mostly with information of the state of the power grid, like big bulk power grid. I mean, not individual use, at least the bulk of the power grid of companies, like the ISOs control something, and I thought, oh, well, that's not privacy. We like the paper, I think we should accept it, but I think this shouldn't be accepted this way because it's diluting what it means to be privacy, and I was surprised that the lack of support I got from the other members of the program committee, and I thought, and it made me realize, oh, maybe I'm wrong. Maybe there's like they were saying, okay, you don't need to be so picky. Privacy can be broadly understood, and I was thinking, oh, maybe I was right. Maybe indeed privacy is more broadly than this individual privacy. So so I have two questions regarding that. So I think at the time I was arguing, it was around the time of that the Supreme Court gave this case of that AT&T didn't have personal privacy, but at the same time they were sort of like giving them corporate personhood, and I don't know if that's related to privacy or not. So the questions are, in your opinion, should I continue sort of like, if this happens again in the future, try to argue this is a sort of like a personal privacy perspective, or should privacy be understood more broadly, like protecting the secrets of companies, the trade secrets, for example, and the second one is there, when I was reading the case to inform myself for this discussion of the AT&T decision.
Sorry, can you say which AT&T
Oh,
case?
the Supreme Court, I forgot. It was about 2 years ago, I think, that the Supreme Court said that corporates didn't have the right to personal privacy. Right, so, and during the decision, I guess I can try to find it and forward it later. Okay. But during the decision, it said, it kept referring to personal privacy, but it didn't have privacy by itself. So I was wondering, is there a difference between privacy and personal privacy?
This is a question for Deirdre.
I thought, but do you want to given that there's two questions, do you want to
Yes,
kind of go down the line?
Let's answer. Why don't you answer this last question, then we'll have each panelist will have 21 seconds on the subject of biometrics.
Yes, privacy attaches to natural persons. I think that was the short, pithy answer to the question, and then...
As opposed to corporate persons like AT&T.
So on the biometrics question, which was just generally about biometrics, if I recall correctly, I don't know that I have a great answer for it. Highly regulated in Europe. At the same time, I think there's a certain social element to that is sort of tricky, right? I have an image of everyone's face in my head, and is that a biometric or not?
Any other comments on biometrics?
Well, I was going to say that, part of the video surveillancing that's going on with drones or UAVs, that, part of it is anonymizing biometric information, like facial.
Biometrics can be a really useful tool, right, to control access. Biometrics raise some pretty profound issues, though, as a tool for controlling access, or authenticating more generally, in that we only have so many of them, right? And if we don't want people using the same thing across lots of different institutions, one of my favorite stories coming out of the National Academy of Science Committee I was on was about people cutting off their relative's thumb to use later on so that they could make sure they got access to the benefits on a continuing basis once they were dead. They raise some pretty profound challenges when we talk about things like facial recognition. They're really hard to hide, and date and other things, and they provide a mechanism for engaging in widespread surveillance without any participation by the individual, right? That they can be deployed at some point, we imagine, at scale, and people can frustrate them through different self-help mechanisms. But our ability to basically identify at least one person repeatedly, provides some really significant challenges, to the extent that part of what privacy is about concerns about government or private sector ability, not necessarily to collect data from you, but to follow you and track you and know where you are.
I'll make one very quick point that probably the most revealing biometric is our DNA sequences, and they're subject of all kinds of discussion. one of the few privacy laws that's passed in the last decade is a law that takes a very interesting attitude about the privacy of DNA sequences. It's called the Genetic Information Non-Discrimination Act. It's, I think, an important model for privacy rules. It was a law that was passed actually to encourage people to have their genomes sequenced, number one, for their own personal health, and number two, or that is to improve personal health care, and number two, to enable research into health conditions generally. And the law does not try to limit the collection of this very, very sensitive biometric, but instead puts limitations on how it can be used. So under this law, you can't use genetic information derived from genetic sequencing to make health insurance decisions or employment decisions. Interestingly, you can use it to make life insurance decisions. But that's just an example of one way that we've approached the legal rules associated with one very sensitive kind of
Can I just add one thing? And one of the other really interesting aspects of that law is that it doesn't limit the use of your information for decisions about you. It limits the use of that information for decisions about other people in employment context, right? Because it's the model of protecting privacy by facilitating individual control over the disclosure and use of information doesn't work because my information, of course, reveals things about many other members of my family, right? And so that kind of binary, siloed model doesn't work very well, and the law reflects that.
Biometrics.
Okay, from the technical perspective, biometrics is should be treated as an information. It is an example where you can actually draw the information security solutions to protect biometric information rather than compared to other type of data that you normally have. So you will treat this as an information security problem, although they have privacy implications.
So I guess I just see biometrics as one class of identity management technology. So I think it's, it's got its pluses and minuses just like other identity technologies. As far as genetic information and genome sequences go, I'd just like to point out that it's actually a potential very interesting application of differential privacy. You could have a lot of genomic data, a lot of genome sequences that are used by, if you could develop differentially private ways to query them and to do research using them, you could use them without actually revealing the genome of an individual. So this is like a perfect fit for differential privacy. And I actually was involved in a huge NIH grant, multidisciplinary NIH grant proposal that included that and didn't get funded. So maybe I'll have another chance.
Jeanette, you have the last word.
I don't have anything more to add on biometrics, but I think the two questioners had raised lots of issues which I think are all fair game in terms of privacy research. And it's really up to us as a research community to go ahead and define what we mean by privacy. And I agree with Joan, there are many, many concepts. It's not just one definition because there are many, many contexts. There's many kinds of information. There's many kinds of uses of that information. And there are many kinds of uses for different purposes of that information.
So I think that's the perfect end to the panel. If there's one thing that struck me about both the topics that the panelists have brought up and the questions that were raised, they range across an extraordinarily broad spectrum of technical and non-technical disciplines, and really an extraordinary broad spectrum of social activities and public concerns. So there's a very broad agenda here. I want to thank Deirdre again and Thomas for bringing the discussion to this conference, and this has been videotaped. I guess we could have warned the audience in advance of that, but we didn't. If you want to be forgotten on the videotape, talk to Thomas. So thank you all very much, and have a good evening. Then please thank the panelists.